So in geometry, the first day is kind of dry because we have to define some stuff. Once we start defining stuff, we can start using it. Okay? So it's just a little bit weird to start with, and you might have seen some of it, you might not. So one of the first things we talk about are points. Now, in geometry, a point is labeled with a capital letter. You've probably seen that. When you guys did slopes, when you guys wrote equations of lines, you had to be given ordered pairs. Remember how you were given ordered pairs? See, point A was at the ordered pair of 3 and 2, and so on and so on. So if we're talking about a point is just a dot, and it's labeled with a capital letter. Point A. B. You have points. How many points, you know this, how many points do you need to make a line? 2. You need 2 points to make a line. Now, when you make a line, oops. Obviously, you have 2 points that make the line. When you have points, how do you label points? With what kind of letters? The alphabet, yes. The alphabet already have letters. Very good. I'm proud of you. Proud of you. We use capital letters. Okay. So if I have a line, 2 points determine a line. We'll call this point B and point C. Do you guys know what those arrows mean when it goes through it? Yeah, exactly. And infinite just means it continues in both directions forever and ever and ever, infinitely. Now, the way that you can label this, the way that you would label this then would be line BC, and you put the 2 arrows above it. I'm sure you have all seen that before, right? Now, line BC means I started at B, went through C. Can I say CB? Yeah, it's the same line. It's just you're just walking the other way. It's not a big deal. These are the exact same things. Oops. As long as that double arrow are above the letters, perfectly fine. There's one other way that sometimes they will write out lines. They might use a lowercase cursive letter to say it, like line L. They might say lowercase cursive L, lowercase cursive K. You see that a lot. Lowercase cursive Q's. But sometimes you'll see just a lowercase letter in cursive to show that it's a line. That should be all the same, right? You guys have all seen that, right? The cursive ones as well, I would imagine. Do you remember what a plane is? Do you remember what a plane is? Can you draw it? Go ahead. Fireside chat here. You did something there. What were you talking about? You're right. A plane is a flat surface that extends in all directions. Okay, so if you think of your desktop, that's a flat surface, isn't it? So if your desktop extended in all directions, that means it would move north all over infinitely, it would move east infinitely, move south infinitely, move west infinitely. That's what would be considered a plane. Now, do planes have to be horizontal to the ground? Can planes be vertical to the ground where you're at? Think of the back wall. Could that back wall be a plane? Yeah. Is the ceiling a plane? Yeah. It just so happens that it has intersection points that's chopped off. And that's where you get segmented pieces to it. Is your piece of paper a plane? It is, but it's just not drawn out infinitely because that would be one hell of a piece of paper. Okay. So it doesn't work. So the idea of a plane is that you have a flat surface, like you were saying, that extends in all directions infinite. So planes, and you've probably seen this, how they draw this also. Planes look like that. Ready for this one? Ready? Makes me funny. Of course I'm having fun. Oh, it didn't work. Sometimes it'll work when it spins while it's moving. Anyway, so I'm like a child with a toy, okay? Look at this, it's shiny. A plane, flat surface. That extends in all directions. Infinitely. Are you okay with me using a symbol for infinity? You guys have seen that symbol before? Sideways 8? Infinitely, and I just put the LY next to it. A lot of times people will draw planes like a parallelogram. Have you seen it like that? In order for a plane to exist, there have to be 3 points that are not on the same line. You need to have 3 points that aren't on the same line. So let's say D, E, F. 3 points not on the same line. Oops, make a plane. Okay. 3 points not on the same line, make a plane. When 3 points that aren't on the same line, we say that they are non-collinear. Think of the word linear. What does that sound like? Line. Collinear, shared line. Non-collinear, not shared line. We'll get into that here in a minute as well. A lot, when you say that you have a plane, you then use the 3 capital letters. Does not matter what order they go in. I would just call this plane D, E, F. And that's how I write it. It's plane D, E, F. There's no symbol, there's no arrows, there's no bar over it, there's nothing. It's just called plane D, E, F. From time to time, you may see, instead of it just being called plane D, E, F, they might put that little parallelogram next to it and call it D. Oops. They might write it like that also. Either way is fine. You're just telling me it's a plane. The 3 points that make the plane aren't on the same line. Plane D, E, F. A lot of times they'll just draw it like that, with a parallelogram like that. You don't normally see it as squares and stuff, because then people start thinking, oh, it's just a square right angles. They usually, textbooks and even upper level books, they usually just show it as a parallelogram. I don't know why they chose that. There's actually other types of planes that we don't learn about in geometry in this class. For example, when I took my math courses in college to get my degree to start with, you had to take what's called axiomatic geometry. Sounds really awful because it is really awful. In that class, it's a study of how all of these theorems and parts and pieces work, of why they work in the background. You can get into crazy stuff about it, but what we learned in there, not only is there the traditional, what we call a 2-dimensional plane, which you guys are accustomed to be using, that's when you would graph things and whatnot. You have what's called a three-dimensional plane. Three-dimensional plane is what you live in. You guys ever heard of what's called the X, Y, and Z axis? The Z axis? When you draw three-dimensional, you guys ever drawn a three-dimensional box? I'm sure most of you have. That's when you get into a different plane. So you can get a three-dimensional plane, or you can get into what's called a when you have a ball, it's a sphere. Yeah, very good. It's called a spherical plane. The sphere is just a ball. You get into it. And again, I know that this isn't anything you're really going to have to worry about in this class. There's one really kind of interesting thing that you can do with this. No, I mean you can. Nothing on my sleeves. So when you get this thing called a spherical plane, I'm going to try this off by drawing it. Let me ask you this before I get too far. When you have a triangle, I think you guys answered this question for me last week. Do you remember how many degrees you can have total in a triangle? 180. Okay. So in a triangle, how many right angles can you have? One. You can only have one right angle in a triangle because you take one 90-degree angle, that means you're only left with 90 degrees left for the other two angles. Are you okay with that? Because if you had two right angles, then you'd have an open top three-sided figure. Now, on a sphere, or a globe, if you will, when you take a sphere like that, you can see this a little better. Sorry, just got really bright. If you start at the top and you work your way, think of that as like the North Pole. You start at the top and you work your way to the equator, and you hang a left. Doesn't that make a right angle at the equator? Okay. Which means if I make a turn to come back up to the pole, isn't that a right angle here at the equator as well? Which means if these two are right angles, couldn't this also be a right angle if I went over 90 degrees? Isn't that a triangle then, with three right angles? And you're not wrong about it, you can only have one of them, but if you change your plane, you can have more than one. Again, this is nothing that you have to worry about. Yeah, this is nothing you have to worry about in this class, but it's kind of, if you want to bet your parents at some point in time, hey, mom, hey, dad, actually I can show you something. Like, no, you can't do that. Oh, yeah. What am I? No, it's geometry. Yeah, it is feasible, but again, like I said, this is nothing you have to worry about. I always think it's kind of cool to show. All right, so, but like I said, a lot of times I try to show you guys little things here and there that kind of, I don't know. Most of you are like, I don't care. But some of you are like, oh, that's kind of cool. And then we go on. So anyway, planes, sometimes they will also, not only they use just the capital letters for 3 points, every once in a while they use a capital cursive letter. I can't draw capital cursive letters, but if you see a capital cursive letter, they'll use the real fancy looking ones. They'll make a K, they'll make a G or a Q, because a Q is very curly, I think, as you get into it. So that's what you wind up with those. As I mentioned a minute ago, there's these two terms that we're going to use pretty regularly. Collinear and non-collinear. And collinear just means points on the same line. And then non-collinear that are points not on the same line. The reason why we talk about these is because as we get into tomorrow and Thursday and Friday, we're going to be talking more and more about collinear points. And collinear points allow us to do some very, very simple things. Have any of you guys ever used a tape measure before? Yeah. Okay. Yes, ma'am. Oh, okay. So when you have a tape measure, you're just looking at inches usually. All of those markings on that tape measure are all the same line, aren't they? Those are all collinear points. A lot of times when you're doing something, let's say you only have an 8-foot tape measure and you got a measure going all the way across the room. You'd have to use that 8-foot tape measure a bunch of times, wouldn't you? So you're just adding more to it. So we're going to do this stuff called segment addition, adding two segments together, working with the algebra of that. And it all stems from the idea of having what are called collinear points. Now, 2 collinear points create a line. 3 collinear or non-collinear points make a plane. But if you look at that picture, what do 3 non-collinear points also create? It has 3 sides. Right? Exactly. The triangle is a set of 3 non-collinear points. Okay. So again, you worked with a lot of this. You just didn't know that you were working with the vocabulary of a lot of this. Okay. Do you remember these 3 things? Segments, rays, and lines of what they look like? One of them we've already done. We've already talked about lines. Which of those 3 diagrams depict a line? Very good. The top one does. The reason that the top one does is because it's got the arrows. And it's got the arrows. Okay. So it has the arrows to it. So that one has to be the line. Now, excuse me. Which of those 3, or how about this? Which of the other 2 then would be the ray? The second one. Good. So this one's our line. This one's our ray. And then by process of elimination, this one gives us our segment. Now, what I want to do is take a second and make sure we talk about the difference between the ray and how it gets labeled. Okay? So I'm just going to draw a ray real quick on a separate slide real fast. So we have a ray. We'll say this is X, Y. Where does this ray start? At X. Where does it go through? Y. So what we would call this is that we call this ray XY. We always call it ray XY because the first letter is always where it starts. The second letter is what it goes through. And then what you do is you draw the arrow. The end is over the first letter. The arrow is through the second letter. What would you call that ray? Very good. Very good. This would be ray WZ. The first letter is always the end point. It doesn't matter what direction it's going. The second letter is where it goes through, and you always draw it like that. Doesn't matter what the diagram looks like, but when you label it, your first letter is always the end point. The second letter is what it goes through. Does that make sense? Yeah. When you have rays, these are not the same. Ray YX is not the same as ray XY. This is not how you can do it. Rays can only be written one way. Endpoint first, letter it goes through second. That's the only way you can write a ray. Does that make sense? Again, notice I'm just using capital letters because that's what we always use. And from there. Yes, sir. If you did WZ, and I'm glad you asked that, if you wrote WZ, that means that where's your endpoint? Z. When you draw this out, this guy is always above what it goes first. Now, technically, could you do that? Yeah, but it's not common at all. This is not wrong, but it's not a habit I'd like you to get into. And to be honest with you, this first chapter is really the only time we talk a lot about rays, because as we get into, actually probably as we get into the middle of next week, as we switch more into angles, the lettering becomes a little bit cleaner. So today it's just a matter of just always put where it starts first, when it goes through second. Yes, sir. Mm-hmm. You don't have to. No, you don't have to. No, not at all. Yeah, this is, I was just showing it for where the endpoint to go through. That's perfectly fine. It's kind of redundant. If you did, you're not wrong. It's just not very common. And then lastly was the segments. And when you have a segment, the segment just has a start and a stop. Let's say it's M N. It's a start and stop. From here to there, from there to here. It's segment M N. How we would write that is this: M N, which is the bar over the top. Does it matter which way you go? Nope. MN is the exact same thing as NM. These two are the same. If from here to the door is 7 feet, from the door to there is still 7 feet. It doesn't matter which way I'm going. I'm still going the same distance. The distance between 2 points is always the same, whether you're walking from here to there or from there to here. Same stuff. Okay? Again, I'm sure I know that all of you have seen this one as well, correct? Let's see what else we got here. Opposite rays. Opposite rays are a little bit different. Opposite rays are rays that create a line. Opposite rays are rays that create a line. I'll give you a second here. 2 rays. What are the 2 rays here that make the line? All right, so CB and AC. AC is going the wrong way. CA. Okay. So remember, the 2 rays that make the line here are ray CB and then ray CA create the line. Perfect. Couldn't have said it better myself. Absolutely perfect. The point in the middle, and notice, are all those 3 points on the same line? So what are they? Collinear. Very good, man. Look at that. Look how well you guys are doing. You guys are doing great. Way to go. Yeah. Yes, sir. Yep. Yes, sir. Because that tells me that this is the endpoint. It goes through this point. By saying that, by saying CB and CA are opposite rays, that tells me C is the point at which they both share. So one of them goes one direction, the other one goes the other direction. Okay? That shared point will always be the first letter. And it just goes opposite one What's that? No, go ahead. What was that? No, go ahead. Go ahead. What about it? Ish. Yeah, she was. Yeah, we try to have a little bit here and there, but sometimes you need it. Sometimes you'll recognize that, oh, this stuff is super easy. I'm not going to worry about all of these. I can do a couple of them. I'll be all right. Then there's times that you're going to want to go into it and say, so you don't ask more questions. So I kind of started leaving it a little bit more up to you because you guys all know how to find answers to everything. So I hope that you're checking your stuff. I want you to check your stuff. I want you to see if you got it right. If you didn't get it right, I want you to ask for your honest feedback of what you did wrong. That's my goal here, to make sure you guys start thinking. Okay? Probably. Intersection. This is such a dumb definition. I hate it. What does an intersection mean? Do they have to be lines? All right. Intersection. Where things, oops, run into each other. Where things meet. Perfect. That works. And that's why so many times you will see that textbooks, and you guys all know this, textbooks suck. The definitions are long-winded, and they're very hard to use. But a lot of times, if you're able to take a definition and make it even more user-friendly, why not? Because you guys know what an intersection looks like. You were just saying England and 38. That's an intersection. Those are two roads intersect. They intersect at a specific point. You did this last year in algebra. Last year in algebra, you guys learned about what are called system of equations. Remember that? You figured out where two lines intersect algebraically. Two lines could intersect at one point. Two lines could not intersect, which means they were what? Very good. Two lines could be parallel. Or two lines could intersect at an infinite set of points if they were the same line. You guys vaguely remember that? And that's all right. So you get the idea that two lines could intersect here. Could I say that two segments could run into each other? Two segments could run into each other. Could I say that two rays run into each other? Could I say what would a ray and a plane look like? Think about that. What would a ray and a plane's intersection look like? Remember how we would draw a plane. How would you draw a plane? Like a parallelogram, right? What's that? It could, but when you start thinking about that image, if it was staying flat, there's no way that that arrow could come through without it curving up. That would only work on a curve. That would only work here. So if I went through it, it would stay straight and it would never buckle because the curve had to be there. That was one of those mind bender ones, that Escher stuff. Now, a ray has what? Where does a ray start? At a point, right? So a ray starts at a point and it goes infinitely in one direction. A plane, if you remember, a plane is that flat surface that goes out in all directions. So could theoretically, can I say that's a plane? Okay. Put a dot right in the middle. And then what? Go this way? What else do I have to have though? Another little dot here. So I can say that ray, we'll call it ray AB, intersected How do we make- Is that a G or a Q? I forgot. G? Can I say the intersected plane G by saying that it's in the plane? Can a ray be in a plane? Can a ray go through a plane? It did look like that, didn't it? So, let's see here. What? Is this a plane? Array? What about two lines? Or two planes? What do you do with two planes? Oh, let me say, what would the intersection of two planes look like? They can be on top of one another? You're right. Yeah, that's right. You can have that. It's not wrong. Think about it. What would the intersection of two planes do? Okay. Overlapping, all right. What are those planes, or what are those pictures? Oh, yeah. The wall, okay. What does the wall run into? What does the wall run into? The ceiling. What's the ceiling? What's the ceiling? Think about it. A plane. What's the intersection then of the wall and the ceiling? Where they meet. In our classroom, yes, it is a line segment because there's endpoints. But in theoretical terms, doesn't that plane continue all the way out? No. Think about it. Don't planes extend in all directions infinitely? I know the building stops, but you're not wrong. You're absolutely correct in when you said that the intersection here is going to be a segment because what we've got is our plane is a segment, the ceiling is a segment. So the intersection has to be a segment. But take the real world out of it for a second. Think of it in theoretical terms. This wall continues forever, right? What's that? Correct. Nothing ends, nothing begins. Right. So if this is an infinite wall, and the ceiling is an infinite wall going out, what would that segment do? It would be infinite, wouldn't it? Perfect. That's where it goes. So two planes can overlap. Does that make sense when I'm saying that it's going to be a line? She's absolutely right by saying, no, that's a segment because it stops. But yeah, it does because it has to stop because we're in the real world. When you get in the theoretical world, that's going to be continuous. In our classroom, it's non-continuous. It stops because we didn't build the wall forever and ever and ever. So this being a segment, start thinking of it in terms of theoretical. It would be a line then, wouldn't it? So two planes can intersect and create a line. So there's a couple of different things here. And that's the idea with the stuff that we're going to do today. There's going to be a couple of things that you're going to try and draw. There's a couple of things you're going to label. There's a couple of things you're going to have to really think outside of the box of what it's going to do. And it's going to be kind of weird. But the best thing that you can do is just try. Okay? That's what we're getting at for today. There's a lot of little things like that. What can you come up with? This is one of those things. People have asked about these terms. Don't write this down. Don't write this down. Postulates, axioms, they're like definitions on crack. They're a little bit more. No, seriously. You guys have heard of you've heard of theorems before, right? You've heard of laws, like the law of gravity, that stuff. Think law of gravity, theory of relativity, which actually is a law now. Postulates, axioms, definitions. They're just all ways of showing how things work. You don't have to know what that means. I just want to. People ask what that is when they start seeing the terms. We'll start seeing these things called postulates, definitions. It's just ways of writing things out. I'll leave that. So I'm going to post this, but I want to double check these numbers. It might be a couple I don't need you to do, or even worry about. I have a little sign out thing right here. It's gonna sign out. No, I don't. So guys, remember, the book stuff you'll have to go through the logins from Pearson to get to. Let's see here. What do I have? 1816. Don't do 27, 28. Those are stupid. Yeah, give those a shot. See how you do. The first grouping are pretty quick. Yeah. Okay. Remember, sometime throughout the day today, take a second, go to the Pearson website, and then screenshot it's on page 16 and 17. Screenshot those 2 pages because you don't need the internet to look at a screenshot. That way you've got it. Or if you want, I've got the textbook right here. If you want to take a picture of it, by all means, go for it. And give those a try. We'll go through it tomorrow, and then we'll start talking about segment addition and things like that. Okay? Nope. And they're cheap. You'll be fine.